Activity 1. Today we're going to talk a lot about series and sequences, the differences between the two in general, and then talk specifically about arithmetic sequences and series. Now on your sheet you should see here a bunch of different types of sequences, and see if you can kind of identify some of these patterns to start. Some are trickier than others, but you may notice that with this first one, every other number is 1. So it's 1, 2, back to 1, then to 3, back to 2, or back to 1, then 4, back to 1, 5, continuing on. Next one is adding like 3, 5, 7, 9. The next one, you are adding the previous two sequences or two numbers to get your next. These are all even numbers, but every other one is is negative. And then we have adding 6 each time and multiplying by 3 each time. So what you're going to notice is some patterns are easier to pick out than others. We will be focusing a lot on two different types of sequences in particular, because sequences can have many different patterns, but we're going to eventually talk a lot about arithmetic sequences as well as geometric sequences. And you may have heard of these before, but basically what happens with our arithmetic, it's when we are either adding or subtracting each time. Geometric is multiplication or division each time. So for instance, this is an example of arithmetic where we're adding each time. This would be an example of geometric where we're multiplying each time. And there's many real world examples, like a bouncing ball is a geometric. Money growth, you might have something that's growing or decreasing. Money in an account, for instance, exponentially, or with when you stack things consistently, that's a linear growth, so that's a pattern, that's arithmetic. So these are just a few of many, many, many examples. Now, a sequence in general, though, whether it be arithmetic, geometric, or any of the others up above, is when we write our numbers in a specific order. So term 1, 2, 3, 4, and following this pattern. So A sub n means our sequence as a whole. So we have this sequence as a whole. And that's when we see that capital letter, that's talking about the whole sequence all as one. The A sub 1, when you see that first number, that means that's our first term in our sequence. So specifically the very first starting value. A sub n is what we call the nth term in a sequence. And that might be, term 100, term number 205, but it's just the nth term would be like the 101st term, something general. A sub n minus 1 means the term previous or before our current term, or the A sub n term. A sub n plus 1 means the next term. So it's just kind of a way, like if my current term is A sub n, the term previous is A sub n minus 1, and then the next term beyond that is A sub n plus 1, just using that little notation. A sub 1, 2, 3, 4, again, are just showing those lists of terms in the sequence. And when you see that ... that just means that you have a continuing sequence. So it's going on beyond that. It's showing that it's still happening forever and ever and ever. Now, sigma notation takes our sequence and makes it into what we call a series. So let's say we have a sequence 1, 2, 3, 4. That is a sequence. A series then, or when we add these up, turns that into when we start adding those values up. Okay, so this is going to be what we're kind of idea of a sigma when we're summing. So again, we call sigma when we sum these together. Again, the sum of these. We again call that either sigma, you'll see notation, or sometimes you'll see it called summation notation. So this looks like a big scary Greek letter. Notation. So this sigma here, it looks big and scary. It is not, okay? All that this sigma is telling us is that we are able to add up the sequence. So what do each of these things mean? Okay, well, this is the term that we are starting with. Okay, so we're starting with this term. So usually it's term number 1, but maybe you only want to add up 3, 4, and 5. You might start with 3. This is the ending term number. Okay, so that's where we're going to be stopping our addition. And then this is the rule of the sequence that we are following. So basically what this is kind of telling us is that we are looking for the sum of all terms starting with our first one in this case, the a sub 1, to whatever that ending term is, a sub n. So maybe we want to do 1 to 6 if this was number 6. Okay. So if we see on the top of the next page then, again, that notation, we have our starting term this time is 2, and we are ending with 5. So here's our rule. So to get the sequences here, we're going to take 2, since that's what we're starting with, square it, and then we're going to do 3 squared, 4 squared, and 5 squared, because again, this is our ending value. And again, since we are doing sigma, really what this is saying is we are taking those 5 terms and we are going, 4 terms, and we are going to add them together to get our sum. Okay, that's all that sigma means, is to sum them up. So 2 squared plus 3 squared plus 4 squared plus 5 squared is a total of 54. And our next one down here, this time we're starting with term 0. Sometimes you might see that, which means we are going to just plug 0 in to start for 1, and we're going to then end by term 3. So to find term 1, again, right now our rule is j minus 1, and then j plus 3. And since we're starting with term 0, we're going to plug 0 in first. To find term 2, then, again, we have to do j minus 1, j plus 3. We're going to then plug in the 1. And then we have to do same idea with 2. So we have then 2. And then our last term that we are ending with here was 3. So then our last one that we're plugging into this rule would be the number 3. And then simplifying that. Okay, so 0 minus 1 times 0 plus 3 is negative 3. 1 minus 1 is 0 times 1 plus 3 is 0. 2 minus 1 times 2 plus 3 is 5. And then 3 minus 1 times 3 plus 3 is 12. So this time when we add up those 4 terms, our sum is 14. Now this question down here, if we look, what is the difference here between this and the values up above? Well, notice there's just the number 2, okay? Every term in our sequence is the number 2. And so we have no variable to plug into to find. Okay, now we specifically have here then, after talking about these different equations, the idea of an arithmetic sequence. Okay, and our arithmetic sequences are going to be when we are adding or subtracting. So if we can specifically add or subtract each time, this is going to be an arithmetic sequence. That number that you are adding or subtracting is called the common difference. So even if you're adding, we call it the common difference. How do we get that value? Well, each time you're going to look at the term and then the term before it and check, okay, does this consistently add or subtract by the same value each time? So your current term minus its previous term. So if we look, for instance, going from 9 to 4, we subtracted 5. To go from 4 to negative 1, we subtracted 5. 5 to negative 11, we subtracted 5. So this one is going to be a yes because each time we subtracted 5. In the second one, we are multiplying by -2 each time. So we got 4 to 8 was we multiplied by -2, multiply by -2 again to get from -8 to 16, multiply by -2 to get from 16 to 32, or to -32. So we're not adding or subtracting. So this one is not going to be specifically arithmetic because we are not adding or subtracting.